Hey guys, Mr. Brown here. I just wanted to show you how to derive the units for energy and work. Well, it's really equal to joule, but a joule is equal to a kilogram times meters squared divided by seconds squared. And that probably looks like a bunch of gibberish. I get that. But I want to show you where this whole mess actually comes from. Oh, and what we did here, the joule, we just called it a J just because it's easier than saying kilograms times meters squared divided by seconds squared every time. So for short, we said joule. But yeah, I just want to show you where we get this from. So if we start off with a formula, so I'll start off with a formula for kinetic energy. I know that kinetic energy should give me joules for units. Let's see if that works. So the formula is for kinetic energy is 1/2 mv squared. Okay, so if I start to look at every one of these things in the formula and see what their units are, the units for kinetic energy should be, well, look at the first one, 1/2. There's no units for that, so I'll just kind of ignore that. Mass has units of kilograms. Velocity, the next one there, has units of meters per second. That's not quite what I wanted, but if you look up here, it's velocity squared. So what I have to do is square meters per second. And then ends up being kilograms times meters squared divided by seconds squared. That is exactly that. So it worked out. My kinetic energy does have units of kilograms times meters squared divided by seconds squared. Alright, I just want to show you now how we can get the exact same thing from potential energy. So potential energy, EP, is equal to mgh. EP, so if we figure out the units for mass are kilograms. The units for g, if you remember, that's an acceleration. That's that negative 9.81 meters per second squared. So the acceleration is meters per second squared. So we'll say meters per second squared. And then if I go times my height, so the units for height are meters. Well, if we just simplify this, we can say potential energy is equal to kilograms times meters squared now, because I just multiplied those two together, divided by seconds squared. It worked again. Okay, one last thing. We know that energy, or sorry, I should say, we know that work is just a change in energy. Remember, this work is equal to change in energy. So really, work should have the same units as well. So let's see if that works out too. So what's the formula for work? Work is equal to force times distance. So if I go, well, what are the units for work? I'll say, well, the units for work are, or for force, I mean, sorry, are newtons. And for distance are meters. Well, that's not really what we wanted. What if we look closer at this newton? What if we break that down to its SI units, so like its lowest units? Okay, so we'll work is equal to, well, in newton is a kilogram times meters per second squared. And then I'll multiply my mass again. And then look at that. Work is equal to, for units anyway, I mean, kilograms times meters. Now I'm just going to multiply those two, so times meters squared divided by seconds squared. Kinetic energy, potential energy, and work all have units of kilograms times meters seconds squared, which is the joule.